In this video, we're going to look at how we add user input to a pawn. There are many ways to do this, and you can do this in blueprints and C++. We're going to actually look at doing this in C++, mainly because it gives you some insight as to what's happening at the blueprint level. But generally, you would actually set up the input through blueprints, primarily because input schemes can change pretty frequently when you're making a game, and you want to be able to customize that and reiterate and test on that really quickly. And Blueprints gives you that, whereas putting this in C++ requires that your entire project get recompiled and linked. And even with clever compilation, it still takes quite a bit longer for that turnaround time, especially if you don't have like a massive computing power to get it all put together quickly. There are multiple ways to set up input in C++. We're going to use the pawn in our case, and it's the case that you could also use what is called a player controller. The player controller is sort of an abstraction of an actual controller. So think of like your Xbox or PlayStation controller. And then that sends inputs, what the player is doing by mapping from the project into this controller. It provides that input to your pawn. So your pawn is something that's controlled by a controller. The reason that they do this sort of abstraction is because often your pawns and your players might be similar kinds of characters, and so you can swap out the controller in essence to make it behave differently. And what I mean by that is that the pawn, if it's an enemy or a non-player character, then it's going to have some artificial intelligence set up for it. And that AI, it takes the form of what's called an AI controller. So that AI controller, again, provides the inputs to the pawn, and then the pawn just has functions that determine how that pawn moves and sort of what its abilities are. And if you look further down the tree in Unreal, what you'll find is that the pawn, is a base class, and then there are more advanced classes like characters, which, are like bipeds, and they have animations associated with them and movements. And so there's a lot of, functionality that gets defined there. So let's start simply though with a pawn, and we're going to just sort of make it move around. Now, by default, if you just set up your pawn and let Unreal take control of it, there's a base pawn that will have sort of the movement that we're going to create. But it's useful to look at how we do this on our own manually, so that if you do need to change something, you can change it later. So what I have here is just, of course, a blank scene, and I'm going to create a new C++ class. And this C++ class is going to inherit from pawn. And let's just call this something like flying pawn. And then I'm going to put this in a subfolder called videos flying pawn. And then I will create the class. Now this will take a while to add because I don't have a massive computer here. And so I'm sure you can hear the fans in the background as they spin up to try to cool the system down. So as this compiles, what it's doing is it's putting this code into not only, sort of what the game is going to be, but also connects it to the editor. And this is why when you try to delete something from your project, you're going to run into problems, because your editor is going to sometimes think that the object is still there, but it isn't. And the only way to really get rid of that is to go and delete the intermediate and binaries folder and force your entire editor to recompile after you've deleted a class, and then that will let you actually make it delete, okay, from down here, which is where all the source code is located. So we have this, this folder with my flying pawn. And so I have this object, and I'm just going to take it for a second here and drop it in here. And you'll notice that nothing is drawn. The pawn, by default, doesn't have a mesh attached to it. And if I wanted to do that, I would need to attach one manually. And let me just grab this. All right, so this is going to just open it up a little bit, and it lets me look at what the entire hierarchy is. Here's the pawn, and you notice that all of these are unchecked. This is determining if it's going to, set up rotation from the controller. I'm going to leave it blank so that we can set up our own input. And then there's a few other things. So we'll go ahead and add some things to this later. Let's go ahead and look at the code. By default, Unreal, when you're using a Mac, is going to open up, or really Xcode is going to open up just the actual source files. And instead, I'm going to open up Xcode itself so that I can get the entire project here and work with the whole editor. So here we have the editor and we have the flying pond, and in Xcode I can have it show me both windows by using the assistant. And so this will show me the header file and the C++ file. So what we want to do in order to make our pond move is we're going to just go ahead and create some properties that we're going to add to the system. And I'm going to just come over here to public, and we'll make these U properties so that we can see them. And really, because we're going to do movement, I want to define something that's going to be speed. So before I do this, I'm just going to sort of show you what my variables are going to be. I'm going to create something like max speed. This will determine how fast my pond can move. And let's just start with that. We'll add these other things a little bit later. We'll add some more things to it later. So I'm going to make this edit anywhere. And blueprint, read write. And I'm going to put this in a category called movement. If you don't put that, it's going to put it into the default category. So this gives it a little like section in Unreal that we'll see in the property editor. That will be my max speed. And let's just go ahead while we're thinking about this and set my max speed to be something like 200. So by setting it to 200, we're going to move 200 units per second. Now, if you'll notice down here, we have this function called setup input player component. Setup player input component. And we have a definition here. It will call the base class first to do any setup that the base class might have needed. And we want to set this up in Unreal in order to actually be able to read these. So what does that look like? Well, first we need to go back to Unreal and we need to open up the project properties. There's different ways we can do this. I'm going to go to settings here and I'll go to project settings, and then this will pop up a window for me. And you'll notice it doesn't always default to a tab. This is just where I've located mine, but it's nice to sometimes be able to switch easily to there. And then I need to go to input. When I click on input, what I'll find is this little section called bindings. And there's a lot of other things that are set here, but I'm going to open up my bindings and you'll see action mappings and axis mappings. Now, an action mapping is really meant to be a button press. In essence, something that you press once or you press and hold, and it happens instantaneously. And when you get the result of an action mapping, it's going to be a Boolean value. So it'll be a true or a false, basically telling you like, is the key pressed or was the button pressed or that sort of thing. An axis mapping is similar to what you see in Unity, where it's going to give you a value that's from -1 to 1, but you can scale that depending on how you want your input to work. But this is, you can think of as your analog controllers. So your analog controllers are the sticks that move around, and depending on how far you push it, it's going to give you a value that's either bigger or smaller depending on the distance from the center of that axis. So I've created 3 axes here, and so we have yaw, pitch, and roll, because these are going to be the kind of movements that I want my flying pond to enact. I'm going to use A and D for yaw, and then I'm going to use W and S for pitch, and then for roll, I'm going to use Q and E. Okay, and then the scaling is going to multiply whatever value it gets out of that axis. So it's going to, like I said, it's going to give you a -1 to 1, and so I'm going to flip the result when they press A, it's going to give me a -1, and when they press D, it's going to give me a +1. This is because I'm going to use it for rotation, and I want to get a value that's going to tell me, should I be rotating these to the left or to the right? So -1 would rotate to the left in essence, and 1 would rotate to the right. Pitch, we're just doing the same thing, and roll is the same thing. These are just in different dimensions. So the pitch is sort of the up and down of the nose, and the roll is, think of like a barrel roll. And so that's how I've defined my mappings. And you can add more mappings by just clicking on the little plus. If you don't like one, you can delete it. And then you can, of course, change these values or delete individual things like this. And so just to demonstrate really quick, I can hit plus. So I have a new axis mapping. I can select which key I want it to be. And, if it's a keyboard key, I can, scroll down here and pick any number of these things that I want it to be. and you could do multiple mappings. But I don't need this. I'm going to just go ahead and delete it so I don't mess with it. So that's how I have my axis mapping. And these names are important, just like they are if you've used Unity before. They're important because I'm going to use these names to determine if one of these things has been pressed. So going back to my code, we are going to first bind actions. And so binding an action requires knowing what function you want to call, and if you were binding on a press or the release of a button or various other sort of aspects of how the button works. So let's define a function first to move forward. And, if you think about what this means, in our objects, there, in our vectors, we have a perception of what might be forward. So maybe it's the positive X direction, maybe it's the positive Y direction, or the positive Z. Well, in Unreal, there's a forward vector, and that forward vector is actually the positive X direction. So I'm going to make a function, and I'm going to call it forward. And this is just going to be, I could call it move forward if I wanted to. And then I'm going to go ahead and define it over here. But I need to actually use the class name, so a flying pawn. Forward doesn't take any arguments. And it doesn't really need an argument because, I just need to know if the button is being pressed or not. But also because of the way the binding works, when it calls it, it doesn't actually call it with any arguments. And so I need to make sure that, if it's being called, then, I can't pass anything to it. So whatever I do, I need to write my function the correct way. So I'm going to also define a function called isMoving. A variable called isMoving. This will be a bool. And the reason I'm going to do this is because, when the button is pressed, I need to let my pawn know. What I'm trying to think about, really, if you're wondering why I'm hesitating, I'm trying to think about, how am I going to get it to move during the tick, because the tick is the update that I get from the game engine. And so what I'd really like to say is something like this, like if is moving, then move forward, right? And so then what I want to say is, well, if forward has been called, then what I want to say is moving equals true, which then makes me think, well, I'm going to need to have to have a way to stop this. So we're going to just define another function called stop. And we'll say is moving equals false. So let's go ahead and make sure we declare that function. And now that I have that, I can do the binding. All right, so the binding is going to look like this. Player input component, bind action, forward. So that's where that name comes into play. IE pressed. So this is a constant that tells that, is basically telling the engine, I want to know if the button has been pressed, like what value it is. I'm going to call a function on this object. So when I'm binding the action, I can determine what I'm going to call it on. So I'm just calling it on my own object. And I expect to call the function a flying pawn forward. So call the forward function when the forward action is activated. I also then want to say player input component. I want to bind the stopping. So bind action forward. So I'm going to bind again on the forward, but this time I'm going to bind on IE released. Again, I'm calling it on this object, and I'm going to say a flying pawn stop. Call the stop function when the forward button is released. So that's enough here. This player input component is really, again, more abstraction on how the input is going to work in case you have to do some kind of mapping to the input. And so this would be enough, in essence, to deal with my my button's being pressed and calling the right function. So it'll set it to true if it's forward, or set it to false if it's not. All right, so now that we have this set up, we want to set up our tick function to behave properly. And so, you know, we're going to basically move the pawn if it is moving is true. All right, makes sense. And the way we're going to do that is by saying f vector forward. So we want to get the forward vector, and we're going to do this by just calling get actor forward vector. Pretty easy. And then we want to say set actor location to get actor location plus delta time times max speed times forward. So what is this doing? Well, this is basically like a first order approximation of physics. So we're going to move forward based on the current location plus the forward vector. So we're assuming we're going to be moving forward. That's what this is. It's a vector. We're going to take that vector and we're going to scale it by the max speed. So the forward vector is a unit vector. So when we multiply it by the max speed, we get a vector that's the length of how far we would possibly move given a max speed. And then we're going to take that and multiply it by delta time, in essence, how much time has elapsed. And so this scales it down to how much we could move between frames, because delta time is going to tell us how much time has elapsed between frames. And so, you know, this is just a very simple way to do it. But, yeah, and if you're using physics at some point, you don't want to call set actor location because it's going to break your physics. But for simple, you know, depending on the kind of game you have, it might be simpler to just, you know, set the actor's location like we're doing here. In later videos, we'll see how we can do this with physics instead. But this should be enough to get us going. And so we're going to go ahead and build this. And then once this is built, we're going to test it out. Now, if we go back to Unreal while this is building and look at my input setting, we'll see that forward was, you know, uses the space bar. So now if I hit play, oh, we can't see my pawn because I don't actually have anything attached to it. And so we're not going to know if we're moving or not. So let's go back to my pawn. And I, you know, put my pawn here. So let's add something to it. Let's add a component. And we're just going to add first a scene component. This is going to be the root. And we're going to do this because we want to attach a camera to our pawn, but we might want to rotate the object that we're using, or change the orientation of the object that we're using so that it faces in the direction we want. So since we're flying, I'm going to use something like a cone that I'm then going to attach to here. So I'm going to add another component, and I'm going to just type cone here. It's a basic shape. And we'll call this body, or let's see, spaceship body. Looks kind of spaceship-like. And then from this spaceship body, what I'm going to do is go ahead and rotate it. Let's say -90 degrees. I think that's the way we want it. Yep. And I'm going to move this whole thing up a little bit. Well, I don't want to move it from there because I want to really actually just move the root up. There we go. And I'm going to go back to my spaceship body, and I'm going to squash it down a little bit. So maybe like 0.25. Oh, that's the wrong direction. I did not want to squash it that direction. I want to squash it in the X direction. Make that back 1. Okay, so now we have something that is a very not exciting version looking of like a spaceship. Okay. The other thing I want to do is attach a camera to it. So I want to attach the camera, and I'm going to just, again, go back to my root. I'm going to say add component, and I'm going to say camera. And I'm going to do just a regular camera to it. And I'll just call this player camera. I really misspelled that. So let's rename this properly, if I can. There you go. All right, so now we have a player camera attached to it. But again, looking at it, it's not going to be very good because, I can't see very well with that player camera. So I'm going to just, again, take this, maybe move it back a little bit, move it up a little bit. And I'm going to rotate it slightly so that I have a -10 decline on it. And so this is just so that I can, make sure that when the camera is, when it's looking, it's going to see sort of the front of the cone. I might have to move it back a little bit, I'm not sure, but we'll just leave it like that and see how it goes. Now, there's one thing that we didn't do, which is to tell our pawn that it is going to be the main object, so it's going to receive input by default. And in order to do that, we will go back to our source code again, go back to my constructor. That's my begin play. And in the constructor, we will say auto possess player equals e auto receive input player 0. This will just direct input from player 0 to the pawn automatically. So when we go back to Unreal, we'll have to recompile. And then recompiling will allow us to set that as the auto input. And then the pawn should move at that point. So we will wait for this to compile and we'll be right back. So I had a compiler error and I wanted to show you what I had mistyped. Part of this is because my indexing hadn't finished and so I'm not seeing these errors automatically. The first one is that it's actually called a flying pawn, not just flying pawn. And the second one is when I was typing, I didn't do a double colon. And so we've got to rebuild that to make sure that the input works. One issue that might arise is that I added this object to Unreal before the code was, before I'd added all those changes to it. And because of that, some of the values are serialized by default into this object that lives in the scene. If I put a new version of this object in there, then these values will be set correctly. But right now you'll see that auto possess player should be player 0, but it's not. And so I'm going to go ahead and change that. But if I do come over here to my browser and I add another flying pawn to here, and if I were to drop it in here, what we would see is that this flying pawn 2 will have auto possess player disabled, which it should not. So let's compile it and see what's going on. Oh, there we go. Now it's showing correctly. So just something to be aware of. So if we'd run this, it wasn't going to work correctly. I'm going to go ahead and just delete this object here, and then we can just hit play to test what's going on. I'm hit the space bar in order to move forward, and yay, look, I move forward. Now that we have forward movement added, we want to add some rotation to it. So we're going to add yaw, which is going to be rotation basically to the left or to the right around the axis that points upward. So let's add that by creating a new variable. We'll call it max yaw speed. This will basically determine how fast we can rotate. So we'll make this a U property, and let's just do a little copy paste here, and that will define a left and a right. And this will be the speed that we can return left or right. So then we want to go ahead and set that value here. So we'll say max yaw speed equals global vector constants by 2, 0. And this, it's a vector, so it has 4 elements to it. And so the first one is just going to have pi divided by 2 in it. So I'm going to just use the first element of that. That will just get me however they calculated pi without having to call a math function or something like that effect. So that's going to be the max yaw speed. And again, we want to do a similar thing to what we did before. When we think about it, we want to be able to define a function that is going to be able to turn our ship. So this is also going to be a function that doesn't return anything. So it's going to rely on side effects here. And it's going to take a single argument called the scale. The reason it does this is that, if you remember, we defined yaw as an axis. And the axis is going to return a value here from -1 to 1. So we want that to be reflected here. That'll get passed to this. Let's define what that function looks like. So void a flying pawn yaw float scale. And let's define it pretty simply. We'll say something like current yaw equals max yaw speed times scale. This implies that we need to know what our current speed is, because, you know, it's going to ramp up to -1 from wherever it is. So maybe if it was +1, it'll ramp to -1, and so it's going to take some time over several frames to get there. Which means that we do want a second property here, which we'll just call float current yaw. And these things are useful a lot of times to just expose to the editor. Even if you don't make them writable, it can be nice to write them so that you know, you can see how it changes things immediately. But so I'm going to leave it as edit anywhere, but you could make it different so it doesn't do that. So this will get the current yaw. It'll store it in there, and then in our tick function, we want to deal with the fact that our yaw may or may not be you know, actually a value that's positive, that's close to 0, I mean. So let's do something like this. We'll say if f math is nearly 0. So when you work with floating point values, you're not always sure that you're going to, I mean, you can't really just compare to actual 0 with a floating point value, because you might be really, really close and nothing's going to get you closer. There might be a slight drift on a controller so that it never returns an actual 0 value. So we're going to say is nearly 0. And we're actually doing the opposite of that by using this not symbol here. And then we're going to use some quaternions. So we'll say f quat, we'll call this the yaw quaternion, equals f quat, f vector, up vector, delta time times current yaw. So only change the yaw if we're not close to 0. Let's put some comments in here. And then this quaternion here, if you look at the constructor for the quaternion, it takes the axis we're going to rotate around, which is going to be our up vector, and it's going to then also take the angle that we're going to rotate, and so we're going to take the delta time times the current yaw. So this gives us a vector that tells us how much we want to rotate based on whatever the current yaw is. We then want to get the current actor location, current actor orientation. So we'll call this current quat. And we'll just say get actor quat. Quaternions used to be in blueprints, but they took them out. But you can expose your own quaternion in blueprint if you would like. So we'll just say for the yaw, we rotate around the up vector. That line is pretty obvious. And then we'll say set actor rotation current quat times yaw quat. So we're going to multiply the quaternions to add the yaw quat to the current rotation. In essence, you know, the current quat is going to always represent how much we've rotated every frame. And so it's going to be updated by how much we've rotated. And the yaw quat is going to be how much we want to rotate more around the up vector. So no matter what our current orientation is, we always want to rotate around the up vector because that's the way, your ship control should work. We don't want it to be always along the X, the XY plane or something like that, because then when we're rotated in some weird orientation, it's going to be really hard to figure out how to control our ship. So this should be enough to get the rotation working the way that we expect. So let's take a look. Let's do a quick build and see if that works. So that should do the rotation. We've added the yaw from the input. Let's go back to our system here. We'll do a quick compile here just to make sure that it imports everything into the system. You can build from Xcode and Visual Studio, but it doesn't always update Unreal. And so you should just, pay attention or do like I did since I'm recording a video, which is to hit compile and make sure that it actually works. Okay, so now that it is compiled, we will hit play. We'll hit the spacebar to see if we can move forward. Yes, we can. And left and right, we don't seem to be moving, so there's something we missed. What did we miss when we were doing this? Let's go back to our code. My guess is going to be that we probably didn't do something with binding. Which is the case. So we may be getting the input, but we're not actually paying attention to it. So we still have to do this player input component. And this time we want to say bind axis. Let's back up a second and say bind axis. And what you'll notice here is that we have different arguments that we can pass to bind axis, and one of these is this object method delegate, and with an F method pointer type, and this means it's going to take an argument to it. All right, so what does that binding look like? Well, the binding is of course just like we did before, which is we're going to use the name, so we'll say yaw. And then instead, we're just going to say, we're going to call it on this object. And we will pass in the function pointer, which we pass in with this ampersand, a flying pawn yaw. So here, bind the yaw and send the scale value to the yaw function. All right. Attempt number 2 at flying. We will compile again, and then we will test it out. Okay, so the compile is complete. We will hit play again. Click in our window so we can go. I will hit space. Looks like we move forward. And I'll hit A. It looks like we're rotating left. And I'll hit D, and it looks like we're rotating right. So with this, we get some basic movement. Kind of looks like a car, so we're not quite a flying ship yet. But you can see that we're able to move around in the game using our left and our right rotations around the up vector. Excellent. So that's a great start. So how do you add the pitch and the roll? Well, you add it exactly the way we just did. We added it by simply setting up a max variable, taking care of the current speed, and then rotating around the proper vector, whether it's the right vector, which would be used for pitch, or the vector that we need to use for roll, which would be the forward vector. So hopefully this helps you get your input set up. Like I said, most of the time we would do this in blueprints so that we can access these things. And if you're thinking about like how would you do this in blueprints, well, you'd really just expose these functions to blueprints so that when you get your input, you can call them. You can do this sort of binding of when that input comes in to call, your forward vectors, and then your tick would handle the rest automatically. And so I think that's something that's important to understand here is that, I'm adding, forward motion, I'm adding my rotation all in my tick function instead of doing it, directly in the forward function itself. That way it's really easy to set up the input into Blueprints instead of having to do a lot more convoluted calculation inside of Blueprints. All right, thank you so much.